the last thing that we were doing, we talked about sigma bonds, how orbitals, if they're incomplete, they try to gain electrons, and they pull each other's electrons, and they end up forming sigma bonds where the electron density is right in the middle.
Yeah.
And you had an S and P overlap, and you had a P and P overlap. And
Hmm.
we also talked about multiple sigma bonds. If an atom makes multiple sigma bonds, like this one, an oxygen atom has two orbitals that need electrons. So they end up merging with hydrogen's s orbital. The two sigma bonds are formed.
Yeah.
And then we started talking about pi bonds. And I told you that the first bond is always a sigma bond between atoms. And then you start getting pi bonds. I mean, the first one is always a sigma, and then you have one pi. If you have a triple bond, it's a sigma with two pi bonds. And we talked about an oxygen molecule. If it's forming a double bond, that means p orbitals are overlapping, merging, and there's a sigma bond formed in the middle.
Yeah.
The other p orbitals are sideways. There's a sideways overlap of orbital. So they both try to pull each other's electrons, and the electron density lies above and below the axis,
Yeah.
connecting the nuclei. And I told you about restricted rotation, that previously this atom could rotate
Yeah.
independently, but now its rotation is not possible. And
Mm.
we did a triple bond as well, and we talked about how delocalized electrons are formed, especially in graphite. So we're going to talk about this in detail now. What we're going to talk about is there's a thing called hybridization.
Yeah.
Do you have any idea what hybridization is?
No, I don't think we've gotten up to there in school yet.
So now hybridization. Uh, Let me write down the definition, then we're going to talk about it. It's the mixing
Yeah.
of orbitals to form new hybrid orbitals.
Okay.
Now, so that's a definition. That's a technical definition. What, in simple words, what it means is, I'm going to write that in brackets. It's in simple words, it means that orbitals change
Yeah.
shape when they bond. So when they are bonding, they change shape. And we did all of this. We did all of this. Like, look at the triple bond. All the orbitals have changed shape. I mean, you had three p orbitals over here. Over here, you had three p orbitals because the other atom is pulling the electrons. The orbitals, they get stretched in different directions. Okay, so Amal, is this idea clear that orbitals change shape
Yeah.
when they are bonding, right? I mean, previously the electron was over here in the p orbital, but now because the other atom is pulling it, the electron is now somewhere in this pink area over here. So that's the simple idea of what hybridization is. Acha, but you're going to study, um, and we're going to talk about the first type of hybridization. We're going to be very specific about the hybridization we're going to study.
Yeah.
So the first one is, as the first one is SP. It's called sp3 hybridization, and we're going to specifically focus on carbon atom. Okay, that I mean, but sp3 hybridization is a very general type of hybridization. It happens to other elements as well, but the focus here is carbon. So when does it happen? When carbon is bonded to.
Yeah.
So when carbon is bonded to four different groups,
Okay.
not four different groups, four, or not even bonded. When carbon is making four single bonds. Okay, that's the
Yeah.
That's the proper definition. When carbon is making 4 single bonds, like in a CH4 molecule. So you say that carbon is sp3 hybridized. So
Yeah.
now in a bit more detail. Carbon has a total of 4 electrons in its outer shell. Like if you write the electronic configuration, it's 1s2. The outer shell is 2s2 and 2p2. It's 2px, 2py, and 2pz. How would the 2 electrons be arranged?
Um.
Like
They
2p.
Oh, there would be one in each orbital. Then you fill up the ones that are left.
Okay. So you have, I mean, this is the outer shell. So I'm only focusing on the outer shell. I said, remember, carbon has 4 orbitals. One thing, let me clarify one thing first. When an atom bonds, right, carbon is bonded to, so what does this mean? That 2 electrons are in the same region, 1 electron in some other space, 1 electron in some other space, and there's one space that is completely empty. So, in its simple form, carbon looks like this. Okay, but let me put a circle over here. Not a circle. Let's put a square over here. So in simple words, this is what carbon looks like. That there's one region with the 2 electrons. Okay, so that's fully filled. There's one region which is half filled. It has 1 electron. There's another region where there's 1 electron, and there's one space which is completely empty, right? So,
Yeah.
so in total, like let me make these 4 orbitals. Hypothetically speaking, obviously, I mean that's not their shape. But when it starts bonding, let's say it starts bonding with 4 hydrogens. 4 hydrogens, they see these electrons, right? And they start pulling those electrons towards themselves. So all these 4 electrons are going to be pulled in different directions, right? Is this point clear?
Yeah.
Because they're getting pulled in different directions, the electrons, they distribute themselves. So instead of this electron over here, all the electrons, because of the pull of hydrogen atoms in different directions, they all
Yeah.
kind of get distributed. Okay, so
Mhm.
hydrogen atoms are pulling these electrons in different directions, right? So the electrons, because there is space available in the outer shell, so the electrons, they get distributed. I mean, this electron starts bonding with hydrogen. This electron gets attracted to the other hydrogen. This electron gets attracted to and this one gets attracted to the fourth one. So is this idea clear that instead of the 2 electrons sticking together in the same area, the electrons kind of distribute themselves in all the orbitals? Is this clear?
Mhm. Yeah.
So now this is called the excited state of carbon. This is how carbon, and this is what most atoms do. That the outer shell electrons, instead of electrons occupying the same orbital, if there's space available, okay, so the condition is if there's space available, the electrons kind of get distributed, and in that way, each of the carbon orbitals, they end up making one bond with hydrogen atoms. Okay, is this clear?
Yeah.
Okay, any questions about this?
No.
Just one second. So now what I'm going to do is I'm going to draw carbon's actual orbitals, the outer shell. So carbon has a nucleus, right?
Yeah.
Let's say there's a nucleus right in the middle. Carbon has an S. I mean, carbon has 3 orbitals, 4 orbitals: S, Px, Py, and Pz. So I'm going to draw axis around this. So this is, let's say, my x-axis. This is my y-axis, and over here this is my
Yeah.
z-axis. So I have these 3 axes. On one axis
Yeah.
there's a px orbital with an electron in it. On the other one there's this py orbital with an electron in it, and on the third one you have a, let's say, pz with one electron in it, and then there's one orbital which is the s spherical orbital, right? So there's this spherical region around the nucleus where you're going to find another electron. Okay, let me kind of shrink it. So these are your four orbitals, each one having one electron in it. And you have hydrogens coming in to bond with it. So this thing is going to start, it's going to start bonding with hydrogen. So how would it bond with hydrogen? There are four hydrogens coming in. So now this green one has one electron in it. And there's a
Yeah.
hydrogen atom coming in. It needs one electron. So this is hydrogen's nucleus, and there's one electron in it as well. They both, so they both approach each other. They start pulling on each other's electrons, and the electron density would then be in this area. The electrons would be found in this area. Okay, Amal, is this clear?
Yeah.
So the green orbital over here, carbon's one of the orbitals of carbon, is going to be stretched and pulled towards this hydrogen, which is trying to bond with it or trying to gain electrons. And the lobe on the other side would vanish. Why? Because the electron got pulled to the other side. Okay, is this clear?
Yeah.
I said then, and remember, carbon has four orbitals. Each one has one electron in it. So I said then you have another. I said then you have another hydrogen atom. It needs one electron as well. So it kind of approaches carbon. Carbon has a blue orbital which has one electron. Hydrogen has one electron. They start pulling on each other's electrons. And the electron is most likely to be found in this middle area.
Yeah.
Okay? You be clear, so the blue orbital got stretched and pulled downwards. And the electron would stop going to the other side. So you're not going to draw an orbital over there because there's going to be empty space. The electron would most likely exist over here. So two more orbitals to go, and you have another hydrogen coming in with one electron. And it approaches the pink orbital, and the pink orbital also has exactly one electron. They start, so they start pulling each other, and they're forming sigma bonds. All of these are sigma bonds.
Yeah.
And finally, the orange one, the last one. There's another hydrogen above, and so the orange one is the electron of the orange one. The s orbital is also going to get stretched, and it would change shape. Okay, so and the pink one, the pink one would disappear from this side. So all these orbitals, their electron density would get stretched in different directions. Okay, the spherical
Okay.
orbital would be pulled by the hydrogen at the top. So you have all these hydrogens, different hydrogens coming in, and they're pulling these electrons, and obviously they're sharing electrons because they're not capable of gaining those electrons completely. So you have four hydrogens coming in, and the electrons get stretched or pulled in different directions. Okay? So Amal, is this clear?
Yeah.
I said now in simple words, if I draw a more simplistic version of this is carbon's atom nucleus, and you have an orbital getting stretched in one direction. You have an orbital that's getting stretched in another direction. Then you have an orbital that's getting pulled in some other direction. Okay, let me. And then finally, you have an orbital that's getting pulled or getting stretched to the top. Okay, and who's doing it? It's hydrogen's atom that's doing all of them. Okay, hydrogen is the one that's trying to pull the electrons, and here's your carbon in the middle, right in the middle. Okay, that's your carbon atom. Okay, so
Yeah.
Amal, this is how the new orbitals would look like. These are your bonding orbitals. These are your sigma bonds. Okay, so all of them are your sigma bonds because the electron density lies exactly in the middle. Okay, so Amal, is this clear?
Yeah.
Okay, so this is exactly like the sigma bonds that we studied. Uh, but why do we call it hybridization? Because the orbitals have changed shape because of the pulling of the other atom. The electrons get stretched in different directions, and the orbitals get stretched in different directions. So the orbitals they change shape. So now the thing is, when you look at carbon, there is no 2s orbital because the 2s orbital was what was the shape of the 2s orbital? It was spherical, right? But now you don't have a spherical
Yeah.
orbital. So instead, you give them different names. You start calling them sp3 orbitals because they look exactly the same.
Okay.
Okay, because you can't. The px orbital is unidentifiable now. The px had two lobes. Now the electron got stretched to one direction because of the hydrogen. So it doesn't have two lobes. You can't call it a p orbital. Same is the case
Yeah.
with s orbital. So all these new orbitals, although they are not new orbitals, they're the same orbitals that just change shape. That's it. So they would be now referred to as that carbon has four sp3 orbitals on the outside.
Yeah.
Okay, is this clear?
Yeah, that's fine.
Achha, so remember this. Whenever you see carbon making four single bonds, and let me tell you the shape of this sp3 hybridized carbon atom. This one is it's called a tetrahedral shape, and
Hmm.
all the angles are 109.5 degrees. Let me see if I can see a. So this is what a tetrahedral shape looks like. I mean, this is the best representation that it's like a pyramid with one bond on top. And the good thing about this is that no matter which way you rotate it, it's going to look exactly the same. I mean, you can if this is the bottom, then this is the pyramid. But any place could be a pyramid. Like this bond could be on top, and the three atoms over here they could be forming the pyramid. So no matter which way which way you turn this thing, it looks exactly the same, and the angles remain exactly the same. All of them they have exactly the same angle. So it's a
Yeah.
three-dimensional shape. It's called tetrahedral, and 109.5 degree is the bond angle. So so remember, carbon is making four single bonds. That's sp3 hybridized. And just as an example, let's say you have this molecule.
Yeah.
That's right. Can you tell me in this molecule, one that I'm drawing, which of the carbon atoms are sp3 hybridized?
Um, would it be the ones in the double bond
The when is sp3 when carbon is making?
or four single bonds?
Okay, so which one?
The ones in the end.
Okay,
Ones on the end.
it's going to be the ones that are at the end. Okay.
Yeah.
And so because remember, this is not the shape of the molecule. Okay. This is just the structural formulas that we write, they just represent which atom is connected to which atom.
Yeah.
Okay. So this is not the actual three-dimensional shape. I said the ones in the middle are the ones that are not sp3 hybridized. They're not going to look like this. Okay.
Yeah.
As the next one, there's another type of hybridization because carbon bonds in several different ways. The next one is referred to as sp2 hybridization.
Yeah.
Okay, that one is that one is sp2 hybridization. Now, when does, and again focusing on carbon, when does sp2 hybridization happen? When carbon makes 3 sigma bonds plus 1 pi bond. Or in simple
Yeah.
words, when carbon makes 2 single bonds and 1 double bond.
Yeah.
So 2 single bonds and 1 double bond. So can you spot the sp2 hybridized carbon atom? Which one is it?
It's one of those two in the middle. You got a double bond and a single one.
ठीक है, there's these ones because carbon is making, if you focus on this carbon atom, it's making a double bond and 2 single bonds, right?
Yeah.
Or in other words, you can say that it's making 3 sigma bonds and there's a pi bond over here as well. So these ones, this one over here and this one over here, they're both sp2 hybridized. Now what happens in sp2 hybridization? Now in sp2 hybridization, uh, there's another thing that you could write, and that is that carbon is only bonded to 3 atoms
Yeah.
because it's making a double bond with one of the atoms. So it's only bonded. Only bonded to 3 atoms. Now,
Yeah.
if it's only bonded to 3 atoms, uh, the thing is that carbon is only bonded to 3 atoms. So the thing is, um, uh, how many orbitals did carbon have? It had a 2s orbital, it had a 2px orbital, and it had a 2py orbital. It had 4 electrons, right, in the outer shell.
Yeah.
Now the thing is that when carbon is only bonded to 3 atoms, let's call them X, Y, and Z. So there's X, Y, and Z. These are the 3 atoms that carbon is bonded to. What's going to happen is that carbon's electrons, one of the atoms is going to pull one of the orbitals towards itself, right?
Yeah.
So the 2s orbital gets stretched because there's an atom that's pulling its electron and it gets stretched in one direction. Then the next orbital with its one electron, it gets attracted to one of the atoms, right?
Yeah.
Similarly, the third orbital also gets stretched in different directions. Take it with Z.
Yeah.
Now there are 3 orbitals, right?
Mhm.
That have changed shape. There is no
Yeah.
fourth atom. If there is no fourth atom, that means p orbital remains unchanged because there is no fourth atom, right? Is this clear?
Yeah.
So that means initially, this is what's going on, that one of the p orbitals, the pz orbital, remains completely unchanged. There's only one electron in it, in this area. But the rest of the 3 orbitals, they get stretched in different direction. One goes towards x, one goes towards y, one goes towards z. Clear? Amal, is this clear?
Yeah.
अच्छा, so let me draw what carbon would look like. One electron gets pulled in this direction, the other one. So it's called fan shape. Okay.
Mhm.
So the electrons are getting pulled in different directions. Okay, let me. And the fourth orbital is completely unused. Okay, so that's your p orbital. And the names
Yeah.
of these new orbitals are, these are known as sp2 orbitals, sp2 hybrid orbitals.
Yeah.
Okay, so the thing that
Mhm.
happens is that out of the 4 orbitals, carbon had 4 electrons in 4 different orbitals. 3 ended up changing shape. Okay, so these
Yeah.
3 they ended up changing shape, while the fourth one remained completely unchanged. So is this initial part? Do you understand the initial part?
Yeah.
Okay, so now I'm going to apply sp2 hybridization, like in which molecule sp2 hybridization is happening. So I'm going to pick the molecule of ethene.
Yeah.
So now if you look at ethene, is it sp2 hybridized or not?
No.
How many atoms is carbon bonded to? Like
Yeah. So
what's the rule that when does sp2 hybridization happen when carbon is only bonded to three
three
atoms?
actually.
So what is this carbon? How many atoms is this carbon atom bonded to?
Three.
Okay, because it's bonded to hydrogen and another hydrogen, and on one side it's bonded to a carbon. Okay, so it is definitely sp2 hybridized, right?
Yeah.
What about the other one? This one.
That's sp2 as well.
Okay, that's sp2 as well. So both of them are sp2 hybridized, which means that if they are bonding, they only bonded. Carbon has four orbitals. Remember that. So when they're bonding, one of the electron gets stretched towards one of the carbon atom, one of the orbitals gets stretched towards hydrogen. Uh, the third electron in the third orbital gets stretched towards this hydrogen, right? Okay, is this clear?
Yeah.
And the fourth orbital, nothing happens to it. And the same happens with this carbon atom. Like one of the orbitals gets stretched towards this carbon atom. The other one, the other one, it gets pulled by one of the hydrogen atoms and so on.
Yeah.
And the fourth orbital remains completely unchanged. What do you think would the fourth orbital do now?
Um.
I mean,
With
like
the fourth orbit.
the rest of the three orbitals, they ended up forming sigma bonds. Like they got stretched by hydrogen, and carbon on one side, right? What would this fourth? I mean, the fourth orbital is also empty. It needs an electron, right?
Would the fourth one form like a pi bond?
Okay, so they would eventually end up forming a pi bond, which is why there's going to be a double bond when carbon does this.
Mm.
So, so the end result is that the atoms, both atoms, okay, whenever there is sp2 hybridization, you need two atoms which are sp2 hybridized. Not really. I mean, actually, that's not really true. Uh, it's true only for carbons. So that the fourth orbital, because the fourth orbital has to do something.
Yeah.
Because the fourth orbital is also empty, it needs an electron. So they start pulling each other's electrons, and they end up forming a pi bond. Okay, so
Yeah.
p orbitals are involved in pi bonding, whereas uh, the sp2 hybrid orbitals
Yeah.
so whereas the sp2 hybrid orbitals are uh, involved in sigma bonds.
Yeah.
Okay, so is this clear?
Yeah.
So whenever you see this happening, whenever you see a double bond being formed anywhere in a molecule, This is exactly what's happening. That carbon is I mean, there are three simple normal sigma bonds, and the pi bond is formed by the unused p orbital, which is not attracted to another atom. I mean, it is attracted to another atom, but initially these three they directly form sigma bonds, and the leftover orbitals they end up forming pi bonds. So, which is why
Yeah.
you get a double bond in the middle.
Okay.
Acha, so remember this particular shape. Let me highlight this. You get this shape. That's
Yeah.
carbon sp2 hybridized. I said the next one is called sp hybridization. So what really happens in sp hybridization? Now in sp hybridization, the first thing is when would sp hybridization happen? It's going to happen when carbon I said it's going to happen when carbon is forming
Yeah.
2 sigma
Hmm.
and 2 pi bonds.
Okay.
So it basically means it's either forming 2 double bonds or it's forming one single bond plus plus a triple bond. Okay, so examples of these molecules are going to be let me sort of just one second. The examples of these molecules, sp hybridized carbon atoms. One example is a carbon dioxide molecule. So you can clearly see that in carbon dioxide, if you look at carbon dioxide, carbon is forming sigma bond over here, a sigma bond over here, then a pi bond over here, and a pi bond over here. So it's forming 2 sigma and 2 pi bonds. Or similarly, it could be an HCl molecule. You get same scenario. That
Yeah.
if it's an HCl molecule that's carbon making a sigma bond, there's one sigma bond over here and 2 pi bonds over here. So
Yeah.
in simple words, you can state when carbon is only bonded to two atoms.
Okay.
So the trend is when carbon is bonded to 3 atoms, you get sp2 hybridization. When carbon is bonded to 4 atoms, it's sp hybridization, and this one is when carbon is only bonded to 2 atoms. Now, if I look at a carbon dioxide molecule, okay, so you have carbon and oxygen forming double bonds.
Yeah.
Acha, so carbon has 4 orbitals, right? There's an S, one P,
Yeah.
one Py, one, and Pz one. Okay, all of them are in the second shell. Oxygen has 2 orbitals which are empty, Py1 and Pz1. This one as well, Py1, and the rest are all full. Like if I write the electronic configuration, oxygen's electronic configuration is 1s2, 2s2, and then 2p4, which means that it's going to be 2px2, 2py1, and 2pz1. So all the other
Yeah.
orbitals are filled except for the last two. Okay, they need electrons. I said now, how would carbon bond? What would happen is, let's this is carbon in the middle, and this is oxygen over here on the sides. Okay, it's the nucleus of oxygen atoms. What's going to happen is the first thing that's going to happen is one of the orbitals of carbon is going to get stretched in one direction, and the other one is going to get pulled in the other direction.
Yeah.
Okay, because there are only 2 atoms, right? So out of the 4 orbitals, one of the orbitals is going to get pulled or stretched towards one of the oxygen atom, and the other one is going to get pulled. So I'm going to cut them out. Okay, so, or just put a tick on top of them. So two orbitals, they get stretched. And what does oxygen do? Oxygen is also going to do. So oxygen has this, let's say it has a py orbital, and they're going to start overlapping in the middle, right? They're going to pull each other, and they would start to overlap in the middle part. Okay?
Yeah.
So the two electrons are going to merge, and this is going to be your carbon atom. Okay? Amal, is this clear?
Yeah.
Just a second. I said, in oxygens, these lobes are going to shrink. Why? Because the electron would now prefer to stay in this other part.
Yeah.
Okay, so here's your carbon atom in the middle. Okay, this one over here. One of the electrons got stretched in one direction, the other one got stretched in the other direction. So, but oxygen has another orbital, which is which is the let's say the py orbital, right?
Yeah.
That also needs electrons. Okay, so this one also has one electron in it. It needs an electron. Carbon has another orbital which is py. So let's say the py orbital. What are they going to do? I mean, it also has one electron in it. What are they going to do? They're going to start overlapping above and below, right?
Yeah.
So they would start to overlap, and the overlapping would happen above and below the sigma bond that's already formed. Okay, so the electron density would be maximum in this middle part and lesser on the sides. Okay, so is this clear?
Yeah.
So this oxygen has bonded. I mean, both of its orbitals have bonded. Like the py bonded with carbon, and the pz also bonded with carbon, right? So is this clear? This oxygen is done. Okay, its bonding is complete. It got its two electrons. And carbon's three of the orbitals are now have now taken part in bonding. Like one of the orbital went and bonded with one of the oxygen atom, the other one bonded with the other oxygen atom. The third orbital of carbon ended up forming a pi bond with one of the oxygens. Okay, is this clear?
Yeah.
And so what you're left with is, that this other oxygen atom, and let's say there's this z-axis. This other oxygen atom also has an orbital that is still unused. Like the py is as bonded, but the pz is still, it has one electron, it needs one electron. So here's
Yeah.
your so here's your carbon. So now here's your carbon atom. It also has a pz orbital, the fourth one. And they both need electrons, and they start to overlap in front.
Yeah.
So so the main point is, do you get the idea that carbon had a total of four orbitals? Uh,
Yeah.
one of them bonded with oxygen ended up forming a sigma bond. The other one, when it bonded with oxygen, ended up forming a sigma bond. But two of the orbitals, these two orbitals, they did not change shape. These ones, the py, the pink one over here, and the orange one, which is pz. They did not
Yeah.
change shape. And they helped carbon form a double bond on both sides. Like there was an oxygen atom with a spare orbital, so that spare orbital became parallel to this one, and they ended up forming pi bonds. There was another oxygen atom, slightly rotated version of that oxygen atom. It had a pz orbital, and that bonded with the other orbital, which for the last orbital of carbon. So two pi bonds are formed over here.
Yeah.
So you're getting two pi bonds and two sigma bonds. So there's a pi bond over here and a pi bond over here, and in the middle there are two sigma bonds. Okay, so this is how a carbon looks like when it's bonded to two atoms. So it's going to be forming two double bonds. So in simple words, this is what it's going to look like. Like there's going to be carbon.
Yeah.
One of the orbital gets stretched in one direction, that's sp hybrid orbital. The other one gets stretched in the other direction, that's another sp hybrid orbital. The fourth orbital remains unchanged. Here, that's your fourth orbital. Oh, sorry, the third orbital. And the fourth also remains unchanged. So there's going to be a p orbital over here. So two orbitals, two hybrid orbitals formed. Plus two p orbitals. Okay, Amal, do you get this point?
Yeah.
So just a recap, quick recap. When carbon is forming four single bonds, all four orbitals they get stretched in different directions, and the shape is tetrahedral, and the angle is 109.5. When carbon is bonded to only three atoms, so three of the orbitals they change shape. One gets pulled in one direction, the other one, the fourth one. The fourth orbital remains unchanged, and that is getting involved in forming a pi bond. And I have to write the shape of this particular orbital, and the shape of this orbital is trigonal planar. It's fan shaped,
Yeah.
and the angles are 120 degrees. Okay, because the three atoms, one over here, it's like a fan. The angles are 120 degrees. And then sp hybridization is when carbon is only bonded to two atoms, or you can say it's forming two sigma bonds and two pi bonds. Uh, so carbon has a total of four orbitals. One gets pulled in one direction, that's an sp hybrid orbital. One gets pulled by the other atom, that's a sp hybrid orbital. Two of the orbitals don't do anything, they don't change shape, and they are involved in pi bonding. They can form a pi bond on the right, and the other one could also form a pi bond to the left. Okay, so is this clear?
Yeah.
And I have to write the angles over here. The angles are 180 degrees, and the shape over here is linear. I mean the blue orbitals, okay, they would be opposite to each other. If one is on the right, the other one is on the left. So is this clear? Amal, do you have any questions?
Yeah.
Any questions?
No.
So, okay, we're going to continue with past papers of this. Okay, we're going to have a class tomorrow as well. Okay,
Yeah. What time tomorrow?
same time.
Oh, okay, that's fine.
So, okay, take care.
Thank you.
After.